Dear friends and followers, welcome back to the channel. Previously, we talked about using the Triode Car to learn the basic concept of automation. If you wish to learn more or even try to get into this field in the future, this is a nice entry-level project to start. With that said, I've got the parts here ready, and let's get to work. In the box, we find all sorts of electrical components, a pair of TD motors, and the circuit board itself. This PCB is going to house every component we have here, and these slots have indicators for which component that belongs in the slot, which I think is a nice and friendly design, especially for beginners. Eventually, we'll get them all on here. However, the first thing I want to do is to get this edge connector soldered on right away, because this component takes up a huge amount of space and will become a hassle to move or adjust later on. So this is the #1 priority. This is a soldering tool I'm going to be using, a simple soldering iron with adjustable temperatures. This is a good feature for beginners as you have more control of the stick. Some soldering irons without adjustable temperatures can get super hot and it'll just straight up damage the board and basically ruin your whole day. I'm going to set this to roughly 300 degrees. Usually you don't have to go that high, but I find it the most comfortable as the solder melts as soon as I touch it. If the temperatures are too low, you just have to place it on longer. One cool trick to check if it's heated up is to smell it. Be extra careful with this as you don't want any part of you to be grilled. I'm going to position the connector to its rightful place, flip over the board, and solder the two joints that hold the connector in place so it doesn't wobble. Now it's time to solder on the connector pins. And the way to do this is very simple. Put on some flux or soldering paste and just feed the solder onto the pins. The extreme heat from the stick will separate the solder nicely and we can just drag it nice and slow. This will take a few tries as a beginner, but with enough practice, you can eventually get it right. While we're at it, I want to quickly install the small comparator chip and the ultrasound connectors. And we're done. Next up, these are the 3 types of resistors used on the Triode Car. the fixed resistor, potentiometer, and the photoresistors. The fixed resistors are the most common component on any electrical circuit. The color bands indicate the resistance of the resistors. The units are measured in ohms. I recommend a search on Google Images resistor color codes to have a better understanding in this part. I'm going to be using this table by electro schematics to show you how to identify them. Basically, all you need to know is the first three bands determine the key value, and the fourth band indicates the multiplier. For example, if the fourth band is orange, then the key value has to multiply by 1,000. In front of me are 5 pairs of resistors for the Triode Car, and we are going to go through each pair and see what their resistance values are. First, let me just zoom in a bit so you can see. Generally, the first band that is the most outwards is the first number. And as you can see, we have the order white, brown, black, and black. What this means is that this resistor has 910 ohms, white being 9 and brown 1 and black 0, with another black multiplier of 1, 910 ohms. I'm going to mark this down real quick and move on to the second one. The second pair here, I could tell the first band here is orange, because according to the color table, orange as the last band actually has no value. So the first band has to be orange. The order is orange, orange, black, black. So this is a 330 ohms resistor. On to the third pair. This one's kind of tricky. We have a gold colored band here. One thing I know is gold and silver bands are only printed on the fourth or fifth band. With that information, we start reading from the right. Blue, gray, and black. So 680 times gold band multiplier 0.1, and we have 68 ohms. Fourth pair, another tricky one. I don't know which one's the first, but the brown is printed kind of funny, so I'm going to start from the right. Brown, green, black, black, 150 ohms. Or if I started from the left, is brown, black, black, green. That's 10 million ohms. I think I'll go with 150 ohms. Seems more realistic, but we can double check later. Last pair. Seems like one of the bands is a bit scuffed, but that's okay. I'm going to start on the other side. Purple, yellow, purple, black, and brown. That's 470 times with the multiplier of 10, 4,700 ohms. Now to double check if we got the numbers right, I'm pulling out my trusty multimeter. I've got it set to 2K ohms, and let's give it a go. First one, 899 ohms. Seems okay. Second pair, 324. Awesome. 68. Beautiful. On the dot. 146. Nice. And for the last one, I'm going to switch the multimeter to 20K ohms, otherwise it won't be able to read the resistance. 4.5K, close enough for me. And that's how you identify the resistance from the color bands. I know the numbers we measured are a bit off, but that's okay. All resistors have this small margin of error called tolerance. If the numbers aren't off by a lot, it should be fine. I've now figured out the exact place on the schematics. If we take a look here, R1 and R2 needs to have a resistor of 68 ohms. I'm going to mark it down real quick. These belong to R1 and R2. And the rest one, R3 and R4, 910 ohms, and so forth. And you can make out the rest. Now it's time to install them. A tip before installing these resistors is these contacts might get a little bit dirty over time. It might feel a little bit rusty or sticky when we hold it. What we can do is take out a small knife and gently scrape it off, so the contacts become shiny again and the contacts are firm. Next up, we have the potentiometer. This is a type of variable resistor. Unlike the fixed resistor, its resistance can be adjusted for different purposes. For example, fans and lamps often use potentiometers to adjust fan speed or brightness. To give you a better picture, I'm going to measure the current resistance, which is about 5.2k ohms. Now I'm going to turn it counterclockwise a little bit and measure it again. Now it's over 10k ohms, basically double than the last one. I'm going to turn it clockwise all the way, and the resistance now is close to none. I'm going to shift the multimeter to a low resistance bracket, and the resistance now is 3 ohms. And that's about it for the potentiometer. Take out the schematics. We can see this slightly different resistor symbol with R_POT. Most likely refer to resistor_potentiometer. And it should be installed on the RV1 and RV2 slot. Let's put it on. Last, we have these resistors, which are sensitive to brightness, hence the name photoresistor. I have a pair of them right here, and one of them is taped above to demonstrate how different brightness environments alter their resistance. I'm going to measure the normal one here, 1.2k ohms, and the taped one is almost 3k ohms, more than double the resistance than the normal one. And these are going to be the main sensors which we are going to use later to achieve the line tracking capabilities of this car. Time to put them on. That is it for this video. If you learned something from this video, be sure to like or comment, and I will see you on our next video, where we'll be finishing assembling the Triode car. Later!